Okay, so today we are going to start our new topic of 10th class, that is real numbers. So that is our first topic, that is real numbers. First of all, we come to the definition of the real numbers. What are the basically real numbers? Okay, so we can write down the definition of the real numbers. Real numbers means numbers which represents any physical quantity in a meaningful way. Okay, so real numbers can be defined as numbers which represents any physical quantity, any physical quantity in a meaningful way, in a meaningful way, are called real numbers, are called real numbers. Okay. Now, what is the meaning of the basically physical quantity? Physical quantity means any quantity which can be measured physically. For example, time, speed, distance. These all are the physical quantities because these values can be measured physically. Now, if you want to give the another definition of the real numbers, we can write in more mathematical terms like this. Any number which can be represented on number line. Any number which can be represented on number line. On number line is called real number. Any number which can be called real number. Okay. Now, what is a number line? Number line is a geometrical straight line on which we have arbitrarily defined zero. Okay, that is our number line in which we have arbitrary numbers on the right hand side of the zero are positive and numbers on the left hand side of the zero are negative. Okay, so here we are clear with the definition of the real numbers. Real numbers means numbers which represent any physical quantity in a meaningful. Okay, now we come to the some more type of numbers that will be useful for us in this chapter. Okay, next we deal with the prime numbers. So second type of numbers we will classify that are the now. What are the prime numbers? What are the prime numbers? Natural numbers having two distinct factors. Natural numbers having two distinct factors. Two distinct factors. Two distinct factors are called prime numbers. Okay, means any natural number which has only two distinct factors. One is the number itself and the second one is the 1. Okay, for example, it's 2, 3, 5, 7, 11 and so on. These all are the examples of the prime numbers. Okay, if we observe these prime numbers, okay, 2, then it is only two factors. One factor is 1 and next factor is number itself, that is 2. That's why it is a prime number. Okay, now if you observe all the prime numbers, we can conclude some important properties of the prime numbers. Okay, next let us write down the properties of the prime numbers. Properties of prime numbers. Okay, now we come to the first property. If you observe these all prime numbers carefully, we look that among all the prime numbers, 2 is the only even prime number. Except 2, all are odd prime numbers. So here we can write 2 is only even prime number. 2 is only even prime. Okay, that is very important property. Among all the prime numbers, 2 is the only number which is even as well as prime. Except 2, all the prime numbers are odd. We can write down one more property. That is any prime number greater than 3, any prime number greater than 3 can be written as 6k plus minus 1. Okay, where the values of k varies from where k is equals to 1, 2, 3 and so on. Means any prime number whose value is greater than 3 can be expressed in the form of 6k plus minus 1. How? If we come to the example of 5, we can write 5 6 into 1 minus 1. Okay. After 5, the next prime number is greater than 3 is 7. It can be written as 6 into 1 plus 1. Okay. We can write more prime number, that is 11. That is 6 into 2 minus 1. If we write down 13, then it can be written as 6 into 2 plus 1. Means here we are observing a very important pattern that any prime number whose value is greater than 3 can be written as the multiple of 6 then plus minus 1. 5 is written as 6 into 1 minus 1, 7 is 6 into 1 plus 1, 11 is 6 into 2 minus 1, and like so on. That's why we have written all these prime numbers in this format. Okay, but here one thing we have to observe very carefully, that any number which can be expressed in the form of 6k plus minus 1 is not necessarily be a prime number. Okay, it is not necessary. Why it is not necessary? If we come to the example of 25, okay, 25 can be written as, that is 6 into 4 plus 1. Okay, again it is in the form of the 6k plus 1, but we are aware of the fact that 25 is not a prime number. Means any prime number can be expressed in the form of 6k plus minus 1, but its converse is not true. Okay, now let us solve some problems based on the properties of the prime number. Let's take the first example. We come to our first question. If sum of three prime numbers, if sum of three prime numbers is 100, if sum of three prime numbers is 100 and one of the prime number exceeds other by 36, one of the prime number exceeds by other 36, then find all the prime numbers. Now we come to the solution of this question. How will solve this question? Here we are given sum of three prime numbers is equals to 100 and one of the prime number exceeds the other by 36. So we can take the prime numbers like this. One prime number is x, so definitely next will exceeds first by 36. So we can take it like x plus 36 and final next one is y. Sum of all three prime numbers according to the question is equals to 100. So from here we can write 2x plus y is equals to 64. Okay, now we have only one equation and we have to find the values of x and y. Now here we observe that the sum of these two numbers is equals to 64. Now 64 is an even number. Okay, now if the sum of two numbers is an even number, then it is necessary that both the numbers should be even or both the numbers should be odd. But here 2x, twice of x, it is a multiple of 2, that's why it is an even number. Okay, so there is only one choice for y, that it has to be even. But in the question we are given that all three are prime numbers, x, y, both are the prime numbers. So there is only one prime number which is even as well as prime, that is 2. Okay, there is only one prime number, that's why here we can take the value of y is equals to 2, because 2 is the only prime number. If you substitute these values, then 2x plus 2 is equals to 64. So twice of x is equals to 62. So value of the first prime number comes out to be 31. Okay, and the value of the next prime number is 2. And if we denote the last prime number by z, its value is 36 more than the first. That is 31 plus 36. That is 67. So by this way we use the important property of the prime numbers, that among all three prime numbers 2 is the only even prime number. Now we come to next classification of the numbers. After prime numbers we come to the composite numbers. Okay, now what are the composite numbers? Composite number means numbers having more than two factors are composite numbers. You can write down the definition of the composite numbers like this. Numbers having more than two factors. numbers having more than two factors are composite numbers. If you write down the example of the prime numbers, that can be 4, 6, 8 and so on. Okay, if you observe 4, the factors of 4 are 1, 2 and 4. So this number has more than 2 factors. That's why it is a composite number. Or we can say other way, the numbers which are not prime are also the composite numbers. Here we can put an important note that now we put a very important note here, that is 1 is neither composite, 1 is neither composite nor prime. 1 is neither composite nor prime. Okay, 1 is the number which is neither a composite nor prime. Okay, then we come to our next classification, that is co-prime numbers. So next we can write co-prime numbers. Now what are the co-prime numbers? Co-prime numbers means pair of numbers having HCF is equals to 1. Okay, you can write down the definition of the co-prime numbers like this. Pair of numbers having HCF is equals to 1 are known as the co-prime numbers. Okay, and it is not necessary that both the numbers should be prime. So you can write examples of co-prime numbers like this, that is 2, 3, okay, 4, 9. Here 4 and 9 both are composite numbers, still they are co-prime. Okay, so it is not necessary that both the numbers should be prime. So any pair of two numbers having HCF is equals to 1 are co-prime numbers. Next, after co-prime numbers, we come to our next type of numbers, that is twin prime numbers. So next we can write, that is twin prime numbers. Now what are the twin prime numbers? Any two prime numbers with a difference of 2. Any two prime numbers with a difference of 2 are twin prime numbers. Now we come to the example of the twin prime numbers. Any pair of prime numbers with a difference of 2. Okay, here it is necessary that both the numbers should be prime. So here we can write down the examples. 3, 5. Okay, here the difference between these two numbers is equals to 2. That's why it is a pair of twin prime numbers. Then we can have another 5, 7. Okay, 11, 13. Okay, we can write one more, which is 41, 43. These all are the pair of the twin prime numbers. Okay, among all these prime numbers, difference between these two is 2. Okay, or we can say in another way also that any two prime numbers having at most one composite number between them. Okay, having at most one composite number between them. That are the twin prime numbers. Now how it is possible? 3, 5. Okay, now if we look at the example of this, okay, there is one composite number which lies between 3 and 5. That is 4. So pair of prime numbers having at most one composite number between them are also known as the twin prime numbers. Okay, so that's all about the classification of the numbers. Okay, then we will deal with our next topic, that is divisibility. Okay, that's for today. We will continue in the next class. Thank you.